Welcome to the ultimate Node.js course. In this course, we are going to learn Node.js from very scratch in simple and easy language. So we will see what is Node.js, how Node.js works, some important module concepts, also some built-in modules. After that, we will move to one basic backend application for learning Express.js, which is the most popular Node.js framework. So without any delay, let's start this course. Node.js is the most popular for developers, but it is not a programming language or it is not a framework. Then what is really Node.js? Let's see that. Node.js is simply a runtime environment for running JavaScript code outside of the browser. What I mean by that? So as we know, we use JavaScript code for changing the data on the web page or implement some logic, but we can't run JavaScript outside of the browser. We have to link our JavaScript file with our HTML file and then we can run it on our browser. But with Node.js, we can run JavaScript code outside of the browser. So Node.js provides a runtime environment for running JavaScript code. Developers mostly use Node.js to build backend services called API, or we can say as Application Programming Interface. Now you might ask, what is an API? Basically, it is a way for two programs communicate with each other. Let me explain you that with example. So here is a restaurant. We are sitting on the table 1 and we want to order some food. In this case, what we will do? We cannot directly go to the kitchen and order our food to chef. Instead of that, we will call a waiter. Waiter will take our order and then give it to the kitchen. After that, kitchen start making process of our order and give food to the waiter. And then waiter will deliver the food to our table. So here, waiter is like a messenger who takes our request and pass that request to our destination. And then waiter will get reply message from that destination and bring back to us. So in real world, this table 1 on which we are sitting is our client application or front end. Now we want to get some data about food which is available on the backend. So we will call waiter, which is an API, and send request to it. Now API will transfer that request to server or database, which is our kitchen, and that server or database will share the response, which is the data we want. And API deliver that response data to our client. So now you understand what is an API. API is a way for two programs communicate with each other. So with Node.js, we can build real-world APIs. Also, we can build super fast real-time applications with Node.js. So these services give power to our client applications like web applications and mobile applications. Very useful. And do you know, Netflix, PayPal, Uber, LinkedIn, and many more famous companies use Node.js. Yes, because Node.js makes their services super fast and efficient. Also, PayPal done a great research on Node.js. I will tell you that in just a minute. So to summarize, Node.js is a runtime environment and it is ideal choice for building highly scalable, data-related and real-time applications. Now you might ask, there are many frameworks and languages like Java and ASP.NET which can also build backend services. What is special about Node.js? Why should we learn Node.js? Why it is so popular? First of all, with Node.js, we can build super fast and highly scalable backend services with low cost. Also, people did a great experiment with Node.js. In that experiment, people create its application backend using Node.js and also build the same application with Java plus Spring. And do you know the result of that experiment? It is really shocking. They found Node application built twice as fast than Java plus Spring application and with fewer people. If in Java plus Spring they have 5 developers, then in Node they only need 2 developers, and still those 2 developers build application faster in Node.js. Also, Node application takes 40% fewer files. Also, in Java they have 5000 lines of code, but in Node.js they have only 1500 lines of code, which is 3x less. Also, Node application is super faster, 35% faster response time than Java application. and Node application can serve almost 2x requests per second than Java application. This result shocked everyone, and people immediately migrated many services from Java to Node.js. This is really cool, right? Second, with Node.js, we get cleaner and more consistent code base because with less code, we can do many complex things. Also, it is great for prototyping, which means Node.js is fast and easy to use when building the first version of an application. First version is called as prototype. Also, as we know, in Node.js, we will use JavaScript. So if you are front-end developer, then you can easily learn Node.js without learning a new programming language. And if you learn both front-end and back-end, then you can switch your job role as full-stack developer and improve your career and get more salary. And one more benefit of Node.js is Node.js has large ecosystem of open source libraries, which means there are predefined code for doing particular things. So we can use someone else's code and implement their features in our application. So overall, learning Node.js in 2025 or in future will definitely benefit you and your programming career. So in the previous lesson, we see Node.js is a runtime environment for running JavaScript code outside of the browser. But let's see how Node.js invented with interesting story. So before 2009, JavaScript was like a superhero trapped inside a browser like Chrome, Firefox and many more browsers. In all these browsers, there are JavaScript engine. So when we run our JavaScript code inside the browser passes that code to JavaScript engine process that code and convert it into machine code which our computer can understand. For example, Microsoft Edge use Chakra engine, Firefox use SpiderMonkey engine and Google Chrome use V8 engine, which is the most powerful JavaScript engine among all browsers. And because of these different JavaScript engines, sometimes JavaScript code works differently in different browsers. Now when we use JavaScript inside browsers only, then there are many limitations. We can't build servers or do backend tasks like handling database, user authentication or APIs. Now at that time, a developer, Jan Dell, comes into the picture. He thinks, what if we take V8 engine and let JavaScript run on servers instead of just browsers? So he takes the V8 engine, which is the fastest JS engine, and recode that engine in C++ code, which can run JavaScript code in our machine, and call that software Node.js. And that's how Node.js invented. So Node.js is a runtime environment for running JavaScript code because it has V8 JavaScript engine. This environment is little different than we have in our browser. Like in the browser JavaScript, we have document object for dealing with HTML document. Also, we have window object. These objects we don't get into Node.js. And also, we don't want to access document and window objects because in Node.js, we are creating backend services and document and window objects are for front-end tasks. So why we need document and window in the backend? So with the Node.js, we can do many more things like we can access the file system for read and write files. We can connect with database and store data in database. And also, we can build fast APIs and much more things. Now one question you might ask, how Node.js is super fast? How Node.js works? And we will see that in the next lesson. So we have seen that Node.js is used for super fast and highly scalable backend applications. But how Node.js is super fast? So the reason Node.js is super fast is because of its non-blocking or we can say asynchronous nature of Node.js. Now you might ask, what is asynchronous? Let me explain you with simple example. Imagine here is a restaurant. We have one kitchen here and we have multiple tables. Now first customer wants to give order. So here our waiter go to the table 1, get order, let's say 1 pizza. And then our waiter give that order to the chef in the kitchen. Now while chef making pizza, our waiter will look at other tables. Let's say table 2 wants to give another order. Then waiter take that order and also give it in the kitchen. So our single waiter can handle many tables. He don't need to wait for chef to complete one order and then he can serve another order. He don't need to do that. This is called as non-blocking or asynchronous way. And this is how Node application works. This single waiter is working as single thread of Node.js, whose task is to handle requests. So this single thread can use to handle multiple requests without blocking. Now at the other side of this asynchronous way, we have also synchronous or blocking way. Let's understand that also with the same example. So here customer 1 wants to give order. Our waiter take order from table 1 and give it to the kitchen. And our chef start preparing for that order like pizza. Now as we know, pizza can take time to prepare. At that time, instead of handling other tables, our waiter wait there in the kitchen for complete that order. Suppose it takes 10 minutes. So our waiter will wait there for 10 minutes in the kitchen. And after that, deliver that pizza to table 1. Now at that time, customers on other tables have to sit because our waiter is blocked for 10 minutes. This is called as blocking or synchronous way. Most of the older backend frameworks like ASP.NET or Rails works in synchronous or blocking way. So when someone sends request on the server allocate one thread to handle that request. In our example, it is waiter. Now imagine we have request for getting the list of users. This task needs database operation which can take time. Now if at that time we get another request, then to handle that new request, we need to also give them a new thread or waiter. Now imagine on our server there are 1000 requests. Should we create thread for all those requests? If yes, then we have to increase the number of server hardwares, which is really costly and slow. So that's why applications which are built on ASP.NET or Rails need more number of servers and more maintenance. Now at that time, Node comes in the picture. And as we have seen, Node use asynchronous or non-blocking way. Of course, we can make ASP.NET or Rails application works like non-blocking or asynchronous application, but for that, we need to do extra work. On the other side, Node applications are works by default asynchronous or non-blocking way. So it is really fast and easy to manage. So when we get multiple requests on Node server, Node has single thread. That single thread can handle one request. Now if that task takes time, like find something from database, then our single thread add that task in the list called event queue and move to another request and start handling that request. This event queue will notify Node when they gets data from the database and then our Node will send that data to the request. So in this way, our single thread can serve multiple users, and that's why Node.js is a great option for data-intensive or network-related applications. We can serve more clients without adding more servers, and that's why Node applications are also highly scalable. Now the question is, should we use Node.js for all types of applications? And the answer is no. We should not use Node for CPU-intensive applications. Now what is this CPU-intensive? CPU-intensive means applications which have tasks related to CPU like video editing or photo editing applications. In these types of application, we have a lot of calculation that can use CPU and few options which does the file system or network. And as we know, Node is a single-threaded application. When it performs CPU-related operations, then other clients has to wait to complete that task. Here, Node will lose its advantage of being asynchronous, and that's why we should not use Node for CPU-intensive application. We can use Node for input-output, network-related, or real-time data-related applications. Just remember, we should not use Node for CPU-intensive applications, otherwise Node can use for mostly all kinds of application. So we understand how Node.js is faster than other backend frameworks. Don't worry about the theories. As you build projects in Node.js, you will understand all this very easily. So let's start learning Node.js practically. Now let's see how to install Node.js in our system. First of all, we will check if Node.js is already in our system or not. So open up command prompt in Windows, and if you are using Mac or Linux, then open up your terminal and write node -- version and hit enter. See, here I get this kind of error message: node is not recognized as an internal or external command. This means node is not installed in my system. If you get here node.js version, which means node is already installed in your system, but I highly recommend you to install the latest stable version of node.js. So head over to browser and open nodejs.org. On this website, we get the download Node.js LTS version, which means latest stable version, which Node officially recommend to use. At the time I am recording this course, latest stable version is 22.14.0, but in the future there might be updated version available. So simply click on this version and download will start. Now one question you might ask, is this course stay relevant for the future Node versions? And the answer is yes. This course will stay relevant for any Node.js version, because in this course we are going to strongly focus on the fundamentals of Node.js, and you can use that fundamentals in any Node.js version. So you don't need to worry about Node.js updates. If any major updates occur, then I will update this course according to that. Now our setup is ready to install. So let's open it up. Let me put here. Click on next. Accept the terms and condition and click on next. From here, you change the installation path, but in my suggestion, leave it as it is. Again, click on next and install. And it's done. Now let's check Node.js is installed successfully or not. So back to command prompt or terminal and write node -- version and hit enter. See, now I get here Node.js version 22.14.0. So we successfully installed Node in our system. Another thing we need in this course is code editor. My personal favorite code editor is Visual Studio Code or VS Code, which is one of the best code editor. Of course, you can use any other code editors, but not many editors has that power which VS Code has. And also in this course, I will share my tips and tricks for VS Code. So if you don't have VS Code, then you can go to code.visualstudio.com, download VS Code and install it. It is really simple. Now in the next lesson, we will write our first Node.js code. Now let's write our first Node.js code. So open a folder in which you want to create a project. Here I opened projects folder, and in this folder I create a new folder, let's say first project, and simply open this project in VS Code. Good. This VS Code looks little bit smaller for this course, so let me zoom it. Usually I don't zoom in this much, but with this zoom you can see what I am doing clearly. Perfect. Now let's create a new file here. Let's say index.js. You can use any name, it's totally up to you. Now inside this file we can write our normal JavaScript code which we are used to write. So let's simply create a variable called greeting equals to good morning. And after that we simply console.log hello, comma, and simply add here greeting variable. Save this file. Now you might ask, how can we run this code without our browser? Because previously we are running JavaScript using browser. So to run this code using Node.js, we need terminal. We can use our system terminal and open our project folder in that terminal. Or we can use VS Code terminal. I always use VS Code terminal because it is easy to open. So go to the terminal menu and select new terminal. Or you can press Ctrl plus backtick, it will open here terminal. Now to run this index.js file, we simply write node space and our file name, which is index.js. If your file name is app.js, then you have to write here node space app.js and hit enter. See, here we get our console line. So congratulations, you write your first Node.js code. Now to hide this terminal, we can again press Ctrl plus backtick. Now here we can also add function and call that function, same as we are doing in regular JavaScript. So after console.log, in the new line, we can create a function print message. And in the curly brackets, we simply console.log have a nice day. And after this function, we simply call this print message function. So we can get this console message. Save this file, and to again run this file, what we write in the terminal? We write node space index.js. See, here we get this both console. Lovely. Also, we can use here set timeout function, set interval function, etc. We can add almost all JavaScript code in the Node application. Now you might ask which type of JavaScript code we can't add here in the Node.js project. So in Node.js project, we can add all types of JavaScript code except writing DOM manipulation code like document.getElement or window.location, etc. Because as we know, whatever code we write in Node application, it will run on server, and on server, how can we access document and window objects? Let me show you practically what will happen if we use document in this index.js file. So I comment out all this code using Ctrl+/ or Command+/ and simply write here console.log and print here document object. Save this file, and in the terminal, we again run node index.js, or we can simply press up arrow. It will bring previous command for us. See, here we get error which says document is not defined, and it is also showing us the line. So we can't use here DOM manipulation code. Another thing is we also can't use here browser specific events like alert. So at the place of this console, we add alert, say hello, save this file, and let's run again this file. See, here we get alert is not defined because again these are browser related events. Server can't show alert in the browser. It is the front end who can show alert. So to sum up, in index.js file or any other files in Node project, we write JavaScript code for server, like we can use various modules, handle HTTP request, access our system files, connect to database, build real-time applications, and many more things which we will learn step by step in this course. Don't worry, you will master Node after this course. Just you have to code along with me and try to write code after you understand it properly, not just copy and paste. You have to understand why we write that specific code and then implement it. It is really simple. Welcome to the second section of the ultimate Node.js course. In this section, we will learn everything we need to know about modules, like what are modules, how can we create our own modules. Also, we have some built-in modules like path, operating system, file system, HTTP module for creating server, and much more. So let's start with what are modules. But before that, let me give you one situation. So in the previous section, we created this index.js file. Now imagine this is the backend project of Netflix, which is the really big project. This project has many features like database connection, user authentication, payment gateway, also many other APIs. Now imagine we add this all feature code in single index.js file. How will you manage this? Or if someone told you to add another feature in this same project, then imagine how confusing and difficult it will be. So what is the solution here? Think about it. Here we can separately create these features in different files and then simply import them in the main index.js file. These different small files are called as modules in Node.js. So if I had issue in database connection, I can go to the database connection module and resolve or improve that code independently. So to sum up, module is a piece of code that performs a specific task. For example, imagine you are building a car. A car has many parts like engine, wheels, sheets, etc. This each part is built separately and also it can be replaced or repaired without affecting the entire car. Now in Node.js, modules work similarly. Each module represents a different part of our application, and these modules can work together to form a complete application. And that's why modules are very important part of Node.js. Now we can divide modules in 3 types. First one is local modules. These are the modules which we will create for our own application, like DB module for database connection, payment module for handling payments, etc. Second one is core modules. These are the built-in modules which we get with Node.js. They are already available in all Node applications. For example, FS for file system, HTTP for creating HTTP server or making HTTP request, OS for operating system related functionality, and many more. Don't worry, I will explain you all core modules in the upcoming lessons of this section. Now the third one is third-party modules. These are the modules which are created and published by other developers. If we want to use them, then we have to manually install those modules in our project. For example, express.js is third-party module which helps us to build API fast. Another module is Mongoose for MongoDB, etc. These are third-party modules built by someone else, and we can also use them in our project. Don't worry about all these things, we will go step by step and learn each of them. So to quickly summarize, module is a piece of code that performs a specific task. We can store them in separate files and then we can use them in any other files. Now in the next lesson, we will create our own module. Now let's build our own custom module. So here in our application, we create a new file called mathoperations.js. In this module, we will add some basic math operation and then reuse it in our main index.js file. So first of all, let's create a new function called add and pass here 2 parameters called a and b. And inside this function, we simply return addition of these 2 parameters a plus b. Now you might ask, how can we use this function inside our index.js file? Because we all know when we define function inside one file, we can only use it in that file, not outside of the file. So to use this add function in other file, we have to export this function from this math operations module and then we can import it in index.js file. But before that, let me show you something. So in Node.js, all files have one object called module. In that module object, we have many properties which gives information about that particular module. Let me show you that practically. So after this function, we simply write console.log and print here module object. Now we have to run this math operations module. So open terminal and write node math and press tab. It will autocomplete the file name. See, here we get this module object with bunch of properties. First one is ID, which is the unique ID for module. Next we have path, which is the full path of our project. After that we have export and it is set to empty object. And you guessed correctly, if we want to export add function, then we have to add that function in this export object. After that we have current file name with full path and bunch of other properties. Now how can we add function inside this export object? It is really simple. So here we write module.exports.add, which is the property name, equals to add function. Make sure we don't call here add function, we just add here function name. I know you think this is little confusing, but trust me, it is not. Let me show you that. So simply move this console.log below this module.exports. Save this file, and in the terminal, we again run this file. You can see in the exports object, we have add property and it is set to add function. Also, if you confuse by the same property name, then we can also change here property name like add numbers. Save this file and let's again run this file. See, here we get add numbers property name to add function. Now we can also export more than one functions from the module. So here we create one more function called subtract. Again, we need here two parameters a and b, and inside this function we simply return a minus b. Now can you tell me how to export this function? Right, we simply write here module.exports.subtract equals to our subtract function. Save the changes and take a look. Let's again run this file. See, here we get this new property subtract to our subtract function. Also, it's not necessary that we can only export functions from our module. We can also export variables or objects or array, basically anything we want. Suppose here at the top we create a variable called name equals to, let's say, code plus u, and another variable lucky number equals to, let's say, 7. Now if we want to export only the name variable, then we can only add here module.exports.name equals to name. We don't need to export this second variable if we are not going to use it in any other file. Only export variables or functions which we need to use somewhere else in our application. Now here is the one thing. These 3 lines of code looks little bit ugly because we are repeating module.exports. Is there any shortcut way to write this? Yes, let me show you. So here we can write something like this. Module.exports equals to, and here we pass object and add all properties which we want to export in this single object. So we write add colon function add, another property subtract colon function subtract, and we can set name to variable name. Now this code and these 3 lines of code works the same because here we are setting properties one by one, but here we directly set them in object. So let's remove these 3 lines, we don't need it. Save this file. Let's clear terminal using CLS and then run this same file, and see, here we get the same export object as before. Also, if we know when our property name and passing value name is same, then we can remove this colon and variable name. So this add means add colon add, same as we remove this colon subtract and also colon name. So there are multiple ways to write the same code. Save this and let's run it one more time. See, here we again get the same export object. So now we have properties in the export object and we can access this export object in any other file in this project, and we will see that in the next lesson. So in the previous lesson, we created our math operations module and export 3 properties. Let me also remove this console line, we don't need it. Now let's see how we can access these properties in the index.js file or any other file. So let's remove this previous code, we don't want it. Now to import any module in our file, we have require function in node.js. So we call this function here, and inside this function in quotes we will enter our module path. So as we can see, these both files are in the same folder, So we can write here dot forward slash, which represent current folder. And here we write our file name mathoperations.js. Or we can also remove this .js extension, because if we don't pass extension with our module name, then by default nodejs will take .js as extension. Now what if we have this math operations file in subfolder? Then we have to write here folder name first, and then we add slash file name. And if we have this math operations module in parent folder, then here at the place of single dot we will use double dot. Don't worry, with practice you will learn this. For now, just write dot forward slash math operations. Now this require function return exports object from this module, which we get here in terminal. Let me show you. So here we store this value in variable called math operations. You can take any other name, but mostly we use the same name as that module. So we don't need to remember another name. And here we simply console.log math operations. Save the changes. And now we can run this index.js file. So node index.js. See, here we get the object with those three properties, which we added in the exports object in math operations. So here at the place of simple math operations, we can do math operations.add. And here we pass arguments, let's say 20 and 30. Save these and let's run this file again. See, here we get the addition of two numbers. So we successfully use one function from other module. You can see how simple it is to create module and use it in other files. Just we have to export from that module, and then with require we can use that exports in any other file. Also, we can use other properties like mathoperations.subtract or mathoperations.name. But we can see when we need to use any of these properties, we need to write this math operations dot. So we can use here JavaScript topic called object destructuring. Probably you know about this because it is pure JavaScript topic. But let's quickly see this. So here we write our object and we want to extract its properties as variables. So at the place of math operations.add, we just have to write add. So at the beginning we write const. Now here we have to use curly brackets equals to our object name, which is math operations. Now can you think what we have to write in this curly brackets? Right, we have to write here properties name, which we want to extract from this object as variable. So we write here add, which is our function, comma, subtract, which is another function, comma, name, which is our variable. Now at the place of this math operations.add, we can simply use this add. And we can also add here comma name. Save this file and let's run it in our terminal. See, here we get 50 and our name. Also, at the place of doing object restructuring in another line, some experienced developers like to do in the same required line. So they simply cut this object from here and simply paste it at the place of this math operations name. So we don't need this extra line. Save this file and let's run it again. See, here we get the same result. So if you get confused in this object restructuring way, then you can simply use mathoperations.add method. It's totally fine. At the end of the day, our code should work. Now it is time for little exercise so you can revise modules. So here you have to create a new module in your application called logger. And inside this you have to export two functions. One function will return current date with this expression and another function will return current year with this expression. And then you have to console this result in the index.js file. same as we do in math operations module, and our output should look like this. So give it a try and then watch the solution. So I hope you complete this exercise, or at least you try to solve this exercise. Now let's see the solution. First of all, we create a new file called logger.js. Now here we have to add two functions. So the first function is current date, and in the curly bracket we simply return new date dot toTime string. Now let's duplicate this function. So select it and press Shift plus Alt plus down arrow or Shift plus Option plus down arrow. Let's change the function name to current year, and at the place of toTime string we write get full year. Now do you remember how we export these functions? Right, we use module.exports, and here we simply set it to object, and inside it we write current date to current date and current year to current year function, or we can simplify them by removing the same name. Great, so we export these functions. Now we just need to import these functions in our index.js file. So at the top we add required function and simply pass here our module path, which is ./ because this module is also in the same folder, and logger. Now we can store its export value in variable called logger, or as we did in previous lesson, we can destructure it like this. So add here curly brackets, and see here we get current date and current year properties. Now after this console, we add another console and simply call here both functions one by one, current date and current year. Save the changes and let's run this file in the terminal. So node index.js, and see here we get our output. So you can see how simple and easy it is to create our own modules and access it in other modules. So till now we have seen how to work with local modules. Now let's see some core modules, or we can say modules, which are already available in the Node.js. So head over to nodejs.org, and from the header open its documentation. Make sure here we select other version and select the LTS version because it is the stable version. Here we get all information about Node.js like simple object, console. Also we have many topics explained and how to use them. And we have some core modules like file system. Inside this they explain all its methods and properties. Also we have HTTP module, OS module, path module, and much more. Here we will see some important core modules which we need to create our backend. If you like to learn all of this, then you can read this documentation, but in my suggestion I will cover all important modules. So let's start with path module. Path module is used to work with file and directory paths. For example, when we want to store uploaded image on our server, then by using this path module, we can give that image proper path for saving them in specific folder. Also, if we want to merge two paths or other path related things, then you can use this path module. Let me show you that. Also, we can see here, they show us how can we access this module in our application. Same as we are accessing our local modules in the require function, but at the place of file path, we write our module name. So in our application, I simply remove this code. We don't need it. Now here we write require function, and in the quotes we write node : and our core module name, which is path. In previous node version, we just write the core module name without node : prefix. Also, this will work in current version. So I use this previous syntax. You can use any syntax, it's totally up to you. Now same as before, this require function return exports object from this path module. So we have to store them in variable path. Now you might ask why we don't destructure here this object as we did previously. Yes, we can do that same here, but we don't know its property yet. So it's better to not destructure here. Now let me show you some useful methods of path module. Suppose we want to see some information about specific file. So here we have path.parse method, and in this parse function we have to pass the full path of our file. But how can we get full path of our file? So in Node.js, previously we seen all files have module object which we use as module.exports. Also, all files have another two variables. One is __ file name, which returns the full path of the current file, and __ dir name, which is directory path of current file. Let me show you these two first. So for now, I comment out this path parse method and quickly console.log __ dir name and console.log __ file name. Save the changes and let's run this file. See, here we get the full path of the current directory. Directory means folder. And below that, for __ file name, we have full path with file name. Now back to our file, we remove this both console and remove comment from here using Ctrl+/ or Command+/, and simply in this parse function pass __ file name. So we get some details about this file path, and to print its result, we simply wrap it with console.log. Good. Save the changes and let's run this file. See, here we get this object. First, we get root property, which is the root path of the current path. Here in Windows, we get C:\\. If you are Mac or Linux user, then you will get here /. Next, we have dir, which is directory path. After that, we have base, which is the last part of this path, which is index.js. After that, we have ext for extension, and last, we get name of that last part, which is index. So this parse method is used to get details about the specific path. Now let's see one more useful method of path module, which is join. So suppose in our database we want to store the path at where we store our uploaded image, like profile picture. We want to store that profile pictures in folder called uploads in our project. So here we can use path.join method. Here at the first we need the path of current project. And how can we get this folder path? Should we use __ file name? No, we have to use __ dir name. And at the second argument, we will pass our folder name, which is uploads. So we will get the path of our project folder, and we join uploads folder at the end of this project path. Let's see what we get. So we remove this console and store this path in variable called profile path, and console.log this profile path. Save this file and let's run this file. See, here we get full path. This first part is __ dir name, and we join uploads folder at the end. I know this is little confusing, but don't worry, when we use these modules in our project, this will all make sense. Now here you might ask, can we join two paths manually? Why we need to use here path module? So as we know, for file path, Windows use /, and Mac and Linux user use /. So we get different result in different system. If we manually write path with /, then in Mac we can't find our path. And also currently our project is available locally, and that's why we know its path. But in real world, we deploy our backend application somewhere on the internet, and we don't know the path for that server. So this path module is very useful in this type of situation. Now sometimes we need some details of our server operating system like which operating system it is using or how much memory they have, etc. So for that, we have another core module called OS, which means operating system. So we remove this previous code, and can you tell me how can we access this operating system? Right, we can use it by require function and simply pass here node:OS, or we can use only OS. Now we can store this in variable called OS. Suppose here we want to run specific code for Windows system, and for Mac we want to run something else. So here we can write if condition os.platform. This will return the platform name on which this code is running. So if os.platform equals to win32. If this is true, then we will run code for Windows. For now, we just write console.log hello Windows user. After that, we want to run some code for Mac system. So we add else if and check os.platform equals to Darwin. This is the platform name for Mac OS. And inside this, we run console.log hello Mac user. And at last, we simply pass else and console.log hello user. Let's check this is working or not. Save the changes and take a look. See, here we get hello Windows user. So it is working. Now in OS module, we have many more properties. I don't want to bore you by explaining all properties because that will take a lot of time. But let me explain you two more useful properties of OS module. First one, we can get the total memory of the operating system using this OS module. So os.total mem for memory, and we can simply print them using console.log. Also, we have another property called freemem for getting the free memory. So we duplicate this line using shift plus alter plus down arrow or shift plus option plus down arrow and change this total mem function with freemem. Save the changes and take a look. See, here we get memory in bytes. I have 8 GB total memory and free memory is almost 2 GB. You can see this is the importance of Node.js. Before Node.js, by using simple JavaScript, we can't get these type of details. So that's how OS module is used for getting information of operating system. Now there is another popular core module which we use for interacting with files. For example, with file system or FS module, we can write the file, read the file, update the file, and also we can delete a specific file. So here in the node documentation, we open file system module. We can see it has so many methods and properties. Let me show you how we can use FS module. So let's remove this previous code. Don't worry, I will add all this code in separate file so you can look at it later. Here we want to access core module. So require and in quotes fs, and we store that in variable called fs. Now we simply write fs dot and see, here we get the list of all methods. But what is this? All these methods have two variations. One is synchronous or blocking methods and another is without sync keyword, which means asynchronous or non-blocking. Now as we know, Node is popular because of its asynchronous or non-blocking way. So we have to always use asynchronous methods in Node.js. Node gives us synchronous method for simplicity. Let me show you one by one both. So here we want to get the list of files which we have in current folder. So for that we have method called read directory sync. And here we pass the path of directory which we want to read. So period slash, which is the current directory. And we store this data in variable called data. And at the end we simply log this data. Save the changes and let's see what we get here. See, here we get the list of all files inside this folder. Now let's also see how we can use asynchronous method. So fs.read directory, and same as before, at the first position we pass our directory path, which is /. Now in almost all async methods, we have to pass second argument, which is callback function, which is the function execute when this asynchronous work will complete. And also we can see that in suggestions. Now there are two possibilities for all asynchronous work. We get an error or we successfully complete that work. I know this is little bit confusing if you are dealing with asynchronous work first time. But don't worry, in the upcoming sections, I have complete section for asynchronous JavaScript. So you will learn all this in depth. Now in this function, at the first position, we get error, and at the second parameter, we get our data. So if we get error, then we get null in this data. And if we get our data, then we get null in this error. So for handling this scenario, we can pass here condition. If error is available, then we will log the error. Else, we will console.log our data. Simple as that. Now let's comment out this console for synchronous method, save the changes and take a look. See, here we get again the same data. Now if you want to verify we get error or not, then we can change this path to something else. Save this and run this file again. See, here we get error, no such file or directory. So now you understand how this async methods works. Also, don't worry about this complexity because we hardly use these core modules in our project. Currently, I am showing you just modules, and this file module is little advanced for this stage. So don't worry about this, you will master it when we use them in our projects. Now let's see one of the most important core module of Node.js, which is HTTP module. HTTP module allow us to create a HTTP server and also for handling different HTTP requests. As we know, Node.js is used to create backend for our client application, but currently we only access this backend in our terminal. What if our frontend wants to access our backend? So to interact with web, in Node we have HTTP module. Let me show you practically how we can create server. So same as before, we access HTTP module using require function and pass here HTTP and store that in variable called HTTP. Now can you tell me what is this HTTP module return? Right, it will return HTTP method. Now this HTTP has one method called create server, which is used to create server for our backend application. Now what we will pass inside this create server function? Simply, here we pass callback function. So when someone sends request to our server, this callback function will run. Now let me ask you something. What is the main work of our server? So when user sends request to the server has to return response according to that request. So here in our server function, we need the information about user request, which API he or she request for, etc. So here in this function argument, we get request object, which is the user request details. Now here we have information about request. So our server do its process, and suppose we want to return response as hello world message. So for sending response, here in the function argument, we get here response object after this request object. Also, many developers like to write short name, REQ for request and RES for response. Now to return hello world message, we write response.write and in quotes we pass our message hello world. In real world, we will return data from here. For now, we are just writing message when someone sends request on this server. And here we have to also tell that this response is end here. So we write response.end. This will make sure our response process is ended here. Now here we create our server, but we need to start this server on some port. If you know React, our application will run on localhost 5173 if it is created by white. Now same as that, we have to start this server on some port. Let's see how we can do this. So here, this http.createServer method return our server object. So we store it in variable called server. And after this, at the bottom, we write server.listen, and in this function, we will pass our port on which we want to start this server. Many developers like to run server on 5000 or 3000, but you can give any port, just make sure that port is not used in your system. Here, I like to use 3000. In real world, when we deploy our server, then this port will be replaced by our backend domain name like cartwish.com or tasktrack.backend.com, etc. Also, in this function, we can pass another callback function. This function will run when our server starts successfully. So here we simply write console.log server start listening on port 3000. Save the changes and let's run this code, because without this code running, how our server will create nodejs.js. See, here we get server start listening on port 3000. If you are using Mac and you use port 5000, then you will might get error for 5000 port is already in use, because in Mac AirPlay receiver service running on this port. So you can use another port like 5001, 5002, or you can even use 3000. There is no rule for port number as long as the port is already in use by another service on our system. Now to check this, we need to send request on this port. So open up browser and simply write here URL localhost 3000 or your port number. See, here we get our message hello world. So we successfully create our server and also start this server. So whenever someone sends request on this server, this function will run and print this message. Simple as that. Now currently we are sending request on this port root route, which means home route. But in real world, user can send request to localhost 3000/about or /products. So we have to also handle these different routes on our server. And for handling different routes, first we need the information for which route user sends request. And for that, we have here request object. So we write here condition if request.url equals to in quotes /. This simple / represent the root route. And in the curly brackets, we can simply move this response.write function with holding Alt or Option and up arrow. After that, we want to handle, let's say, about route. So here we add else if request.url equals to in quotes /about. And if it is true, then we simply return another message response.write. This is about route. Like this, we can add as many requests as we want. And after all routes, we will pass else, which means user pass routes which is not handled here. And that's why here we return simple response.write route not found. Also, make sure this response.end function called at the very end of this server function. Save the changes and back to our browser. If we change our URL to /about, can you tell me what we will get here? Let's see. See, here we get the same hello world message, because in our terminal still our old code is running in which we didn't handle routes. So to run this new code, we have to again run our application. So in terminal, first we will stop the application by pressing Ctrl+C in Windows and Mac both. And after that, we again run node index.js. Good. we get here server start listening on port, and in browser if we refresh our page, see, now we get here message, this is about route. And if we try to request any other routes, then here we get route not found. So that's how we handle different API routes using HTTP module. Now imagine we have 20 different API routes, and to handle them we have to write 18 more else if block. And if all those routes has hundreds lines of code, then managing our own server will become so messy. So in the real world, we will not use this HTTP module. For that, we have very popular third-party module called Express. And Express has many more benefits than this HTTP module. And also, using Express, we can divide our routes in different files, so we don't get confused when we have to make any updates or we want to add new functionalities. I explain all these modules so you get little understanding how Node is working and you get comfortable with some JavaScript syntax. So I hope you enjoy this section. See you in the next section. Welcome to the fourth section of the Ultimate Node.js course. In this section, we will start working on our first project. So we start with basics, what is REST API, set up our server using Express.js, then we will create different types of HTTP request, get, post, put and delete. Also, we see data validation and much more. So let's start this section. Now as we know, API stands for Application Programming Interface, and it is the way for two programs communicate with each other. Remember our restaurant example? Let's see another real-world example. Imagine user wants to register on our website, so he or she fill the form and then submit it. The moment they submit, we call API for register a new user. And in the backend, we create a new user. Like this, we can create many APIs for logging the existing user, get all products list, add products to cart, delete products from cart, etc. In simple words, API is used to transfer data between frontend to backend and backend to frontend. We already know that, right? Now you might ask, what is REST API? So REST API stands for Representational State Transfer API. REST API is a specific way of building our simple APIs. Don't worry about its name, it's very simple. So REST API is the same API, but we have to follow some rules to build that API. If we follow some rules, that simple API becomes REST API. Now let's see some rules which we have to follow to make REST API. One rule is we have to define separate API URL for each piece of data. For example, suppose we are creating API for user-related operations like register a user, getting the information of single user, etc. In this case, our API should be our domain name and then /user for register. And if we want to get information about single user, then we create API URL like /user/123. Here, 123 is a user unique ID. Same as if we create API related to products, then our URL should be like this: /products/123/products/add to cart, etc. So by simply looking at this API URL, we get the basic idea related to our APIs, and by that we can easily do changes and our application stay clean. Another rule is different types of actions like reading, adding, updating or deleting data should use specific HTTP methods. Now you might ask, what are HTTP methods? So as we know, HTTP stands for Hypertext Transfer Protocol, and it allows our frontend to request and receive web pages and other resources from servers using API. So only because of HTTP we are able to send and receive data from backend using API. Now this HTTP has 5 main methods: get, post, put, patch and delete. Let me explain you this one by one. First one is the get method. we use get method when we want to only get data from the server. For example, we want to get all users details, or we want to get all products details, or we want to get single product detail. In this case, we define our API with get method. For understanding these methods, we will use analogy of library. So get method is like asking a librarian to show you a book or multiple books. Don't worry about implementation, we will see all methods step by step in this section. Second, we have post method. We use post method when we want to post or send some data from frontend to create a new data in our server. For example, for register a new user, we have to send user data from the frontend and that will create a new data in our server. Think it's like we giving new book to librarian for add the book in library. Next we have put method. We use put method when we want to update an existing data on the server with new data. For example, if you change your profile information on a website and save it, then a put request is sent to update your profile with the new details. Think it's like giving librarian an updated version of a book to replace the old one. Next, we have patch method. We use patch method when we want to update a piece of small data, not entire data. For example, if we want to update just our email address in our profile without changing anything else, then a patch request can be used. Think it's like we are giving librarian just the updated pages of a book to update, rather than replace the whole book. Imagine here we have user object in our server. We want to complete this user object, then which method we will use? Right, we use put method. And if we want to update just the password of this user, then which method we will use? Right, we will use patch method. You are doing really great. So put method is used for whole data update and patch method is used for little update in the existing data. Now last method is delete. And you guessed correctly. We will use delete method for delete data from the server. For example, when we delete a post or a comment on social media, then a delete request is sent to remove it from the server. And for that, I don't think we need library analogy, right? And also, it is not practical. Think it's like asking librarian to remove a book from library. So you can see HTTP methods are very simple. We will use these 5 HTTP methods to define our different types of API. So these are just few rules we currently see, but don't worry, we will learn all these rules as we build APIs. Now you might ask why we need REST API, why we need to follow rules for building API. So by following any rules, we can make things organized, and that's true for REST API also. Rules will make our API more organized. Also, by follow REST API rules, we create a simple and easy to use API because they use specific HTTP methods for doing specific types of work. Also, with rules, we can create a clean and maintainable API which any developers can understand and start working on them. For now, don't worry about rules. As I said, you will learn these rules while you create APIs. So let's start building our first Node.js project. I am very excited and I know you are too. Now before we start any project, it's better to roughly plan about that project. So as we know, our first project is about managing the task. And here how its front end looks like. Also, this is the first project of my React.js course and we will build this project backend as our first backend project. Don't worry, we are not going to create here front end because our main focus is on the Node.js and building the best backend for our applications. From the front end, we just need to call APIs. Now you might ask, how can we plan Node.js project? It is very simple. This is the method I used for planning my backend project, even big projects. Instead of building project first and then doing major modifications, it's better to spend little time on planning before we start our project. So for backend project, if we create the list of APIs That's very useful because backend is almost all about APIs. So for this project, first we need the list of all to-dos. So one API for getting all to-dos. After that, we need to create API for adding a new task. And after that, we can update the single task details. So one API for updating the task. And at the end, we need to delete single to do. So another API for delete specific task. So currently we know we need these 4 APIs and we will create 2-3 extra APIs for practice. If while building project we need to create more APIs, then we will create more APIs. There is nothing wrong about that. This is just a rough plan for reduce the confusion. Now let's create a fresh application for our project. So open the folder in which you want to create project and I name it as task track. And simply open this folder in the VS Code. This is the name of our project. Is it sounds good? I hope it is. If you have better name, then you can also use it. It's totally up to you. Now what we have to do for creating Node.js applications? Do you remember? We just did that in our previous section. Yes, simply we open our terminal and initialize our project using npm init. And for all yes, we will use -y here. See, we get package.json file with some default config. Here we can see our main file is index.js, which is the file runs when we start our application. So let's create index.js file. And that's it. Here in this file, we will write code for our backend. So in the previous section, we create our server using HTTP module. And the problem with the HTTP module is we have to define our different API endpoints in this if and else if statements, which is not very clear and also not easy to maintain for big projects. So that's why we use very popular package or module called express.js. Express.js is minimal and flexible for creating better Node applications. In simple words, by using express.js, we can simplify our routes, we can easily handle HTTP request and response, middlewares and much more things. Let me show you something. Here is the Express package on npm.js website. We can see its weekly downloads are almost 37.2 million, which is crazy. And almost in 90% of Node.js projects, developers use Express package. So it is very important to master Express, right? First of all, let's install this module in our project. So open up terminal and write npm install express. At the time I am recording this course, its latest version is 5.1.0. If you want to get the same experience as I am getting, then you can write here npm install express @5.1.0 and hit enter. Don't worry about Express, it is really simple package. Done. Now we want to use this Express module in this index.js file. Can you tell me what we have to do? Right, we will import the Express module using require function express, and this require function returns a function. So we simply store it in variable called express. Now to create an Express application, we call this express function here, which returns a object, and we store it in variable called application or app. You can give it any other name, but probably all developers called it app. So let's go with app. Now in this app object, we get many useful methods. For example, we have here app.get, app.post, app.put, app.patch, app.delete, etc. Do you remember where we see these 5 methods? Right, they are HTTP methods for creating different types of API. So if we want to define our API for HTTP GET method, then we use app.get. If we want to define HTTP delete method, then we use app.delete. Same as we can create post, put and patch request. The way to define all these 5 methods are the same. Still, we will see all methods in this section one by one. For now, let's start with getRequest. So in this get method, at the first parameter, we have to write our API endpoint name. Suppose we want to define getAPI for URL http://localhost:3000/todos. Now what is our endpoint in this URL? Right, /todos is our API endpoint, and that's what we have to write here at the first parameter. Make sure we add here / first, otherwise this will not work properly. Now what if we want to define getAPI for URL http://localhost:3000, which is the root URL of our website. At that time, we can add here only /, which represents root endpoint. Now we have to define what will happen when our frontend sends request to this endpoint. Do you remember? Let me show you. Here we pass callback function, and in this we get 2 objects, request and response. This request has all details about URL request, and with this response object we can send response related details. We already seen this in HTTP module lesson. Now what we want to send when someone sends request on this API? For now, we simply return a text response.send task track project. So when someone sends get request on this endpoint, this function will run and then it simply returns this text in response. Simple as that. So by these 2 lines, our Express server is created. But we have to run or listen this server on some port. If we don't listen our server, then our API will not work. So here at the end we write app.listen, and simply here we pass our port number, and at the second parameter we again pass callback function which will run when our server started listening on this port. So here we can simply console.log server is running or listening on this port 3000. Save the changes and let's run our index.js file. Write node index.js. See, server is listening on this port 3000. Nice. Now back to browser and run localhost:3000, which is the root URL, and see, here we get task track project text which we send from our server. You can see Express makes our code really simple. We can compare our current code with the previous HTTP module code. Express makes it really simple. Also, this is our first API, that's why we return only text in response. Now as we move forward in our project, real thrill will start. Now it is time for little exercise. I want you to remove all code from the index.js file and again create Express server and create API for root endpoint. By this exercise, you will get familiar of making Express server. Literally, it will take only 1 minute. So try to complete this exercise and then watch the solution. Okay, so I hope you solved the exercise or you tried to solve that. Now let's see the solution. First of all, we need Express module in our file. So require Express and store it in variable called Express. This Express is a function, so we call it here, and it will return our server object or application object. So let's store it in variable called app. Here we create our Express server using these 2 lines, but we have to listen our server, only then we can run our API. So at the end we simply add app.listen, and at the first parameter what we will pass? Right, we pass port which is 3000, and at the second parameter we pass callback function, and inside it simply console.log server is running on port 3000. One thing is, I listen server before adding API because many times I forgot to listen server and it will waste a lot of time. So I always listen the server as soon as I create the server. Now in between, we can define our API anything. So for GET request, we add app.get. At first, we add our API endpoint, and then at the second parameter, we add callback function which has two parameters, request and response. And inside this callback, we simply send text using response.send. This is task track project. Save the changes, and here we have to stop our application from terminal because it is still running old code. So we again run node index.js file. See, server is listening, and in our browser, we get the updated text. Very simple. Now let's create API for getting all to-dos list. Can you tell me which HTTP method we have to use? Right, for getting the data from the server, we use getHTTP method. So here we write app.get, and let's say we want to give this API name todos. So we pass here /todos, and after that at the second parameter we pass callback function which has two parameters, request and response. See, for all APIs this structure will stay the same, only this HTTP method change, this endpoint change, and logic inside this callback function will change. That's how Express.js makes our project simple and clean. Now currently we are not going to work with the database because we don't want to add extra complexity for our first project. We will learn all these things step by step, so don't worry about database. Now here we have to send all to-dos array. So at the top I define one dummy data called todos array and simply add some to-dos in this. So here every to-do is object with 4 properties. ID, let's set it to 1. Task, which is the text of task, let's say create all APIs for project 1. Tags, which are the tags related to task, which is an array, nodejs, comma, JavaScript. And status to do. These properties ID, task, tags, status is defined by Node.js developer, which means you. What you want to call it, how many properties you need, these things you have to decide based on which data we want to store and which data we don't want. Now let's duplicate this object 2 more times using Shift plus Alt plus down arrow or Shift plus Option plus down arrow. Now we change this ID to 2, task to create API for list of all to-dos, tags, nodejs, and status to doing. And at last, we simply change ID to 3, task to plan project 1, tags, JavaScript, and status to done. Now we want to simply return this array as a response when someone sends GET request to API with /todos endpoint. So what we write here? Right, we write response.send and simply pass our todos array. Save the changes and let's verify this API is working or not. Open terminal, close the current running server using Ctrl+C and again run this file. Now in the browser, at the place of root website, we simply call /todos endpoint. See, here we get our array. So that's how simple to send data from the backend using GET API. Now currently, when we do some change in our project, we have to close our previous running server and restart our application. which is really annoying. So for automatically restart our application, we have one package called Nodemon. It is really useful. So open up terminal and write npm install or i-g nodemon. Here we use -g for installing this Nodemon package globally. Otherwise, we have to install Nodemon in every node project. Also, if you are using Mac, then for installing global package, you have to write sudo at the beginning of the command and then it will ask for system password. Now how can we run file using Nodemon? Let me show you. So in the terminal, previously we are running file using nodejs.js. Now for Nodemon, we write nodemon index.js. Simple as that. See, here we get our Nodemon version and for restarting, we can enter rs. Also, it is telling us watching path period, which means root of this project. After that, it is watching extensions like JS, MJS, CJS, JSON, etc. So any file which have this type of extensions, Nodemon is constantly watching those files, and if something changes in those files, it will restart our application. And at the end, see, Nodemon is also running command node index.js. So by using Nodemon, we don't have to restart our application. It will automatically restart when we change something in those files with those extensions. Now currently, we are manually setting the port of our server, but in the real world, that port is set by environment in which our application is running. Specifically, it's managed by the hosting provider or development platforms like Render, Heroku, AWS, etc. So when we deploy our application on these platforms, our 3000 port might be already used by another server. At that time, if we hard-coded our port, then our server will not run on that port and it will give us error in the deployment. So what is the solution here? It is really simple. We will check one condition. If in our application environment, port variable is defined, then we use that port variable, else we use our hard-coded port. Let me show you, it is really simple. So here, before we listen our server, we create a variable called port equals to. Now here, how can we check our server has port in its environment or not? So for that, we have one object called process.env. This env is for environment. In this environment, we get all variables which are set by hosting platforms and .port for port variable. So if any hosting platform want to set different port, then they will store them in this process.env.port variable. That's common convention. Also, all environment variable name is all capital letters, and that's why we also give this variable name as all capital port. So just by looking at it, we know it can be environment variable. Now if this process.env.port is available, then no issue. But if it is not available or set, then we have to pass our hard-coded port value. So we add here OR operator, which is bar symbol 2 times. It is the key above enter or return. And here we pass our port, which is 3000. Now let's pass this port variable at the place of this hard-coded port, and also we will change this console message. Let's make this string as template string using backticks, because in template strings we can easily access variable and change this 3000 with $curly brackets port. So if this environment port is available, then we use it, or if it is false or null, then we use this 3000 port. Simple as that. Currently in our application, environment port is not set. That's why our application will run continuously on port 3000. Don't worry if you are little confused about this process.env. We will see it in details in the upcoming projects. Now let me give you one shortcut for setting up Node application. First, required express, create express application, create this port variable using this expression, and listening the express application on the port. These 4 things will stay the same in all Node applications. Yes, we can add more functionality in other lines, but nothing will change in these 4 lines. Previously, we created API for getting the list of all to-dos in our application. But what if we need to get the information about only single to-do, like to-do with ID 1 or ID 3? For that, we need to pass ID in API URL. So our API URL look like this, /todos/1, which means we want to fetch one to-do information whose ID is 1. This type of variable which we pass in our URL is called as route parameter, and it is very important for providing the specific information about API request like ID, status, date, anything. Let me show you how we can set this type of API URL and access the route parameters. So we add new get API and endpoint to /todos/. Now here for defining route parameter, we use colon and give our route variable name like ID. So this ID is our route parameter. We can call it anything like to-do ID, but ID is short and sweet, so we go with ID. And that's it. That's how we can define route parameter in our API URL. Now let's access this route parameter in our API logic. Again, we add here callback function with 2 parameters, request and response. Now inside this function, what do you think? In which object we get information about our route parameter, request or response? Right, we get information about route parameter in request. So request.params. In this params object, we will get all route parameters and we can access it by .id. See, here we get also auto suggestions. Now let's simply send this ID in our response.send. Save the changes and back to our browser. Head over to localhost 3000/todos/1 and see, here we get ID 1. So we are successfully getting the route parameter. Now here is the one thing. We can also pass multiple route parameters in our API. For example, we can pass task status to do. Now in the backend, we add here route parameter. And how can we do that? Right, we add /:status. And how can we access route parameter? Right, we use request.params.status. Let me show you whole route params object. Save the changes and back to browser. We pass here status value after our ID value. Make sure the order is the same as we defined in our API, which means first ID and then status. See, here we get the params object with those 2 properties which we defined in API. Now you might have curiosity, what if we don't pass here status? Let's also see that. Remove the status value and see, here we get cannot get /todos/1, which means our server didn't found API with this URL. So if we define route parameters in our API, then make sure we will pass all route parameters in right order. Now there is another way to pass data in URL, which is by using query parameters. If you are using websites, then in URL you might see question mark and then pass some types of variables like short equals to date and order equals to ASC for ascending, etc. These are the query parameters which is used for passing data in URL. Now you might ask, what is the difference between route parameters and query parameters? Both are used to pass data in URL, but route parameters are used to pass data which is must required, where query parameters are used to pass data which are additional or optional. In simple words, in our API, if frontend didn't pass route parameters, then our API will give us error. But if we didn't pass query parameters, then our API will not give us error. It is an additional details. In our example, if we didn't pass to-do ID or status, then it will give us error that API not found. But if we don't pass these variables after the question mark, then we don't get error. Now let me show you how we can access these query parameters in our API. So for that, we don't need to change anything in the API URL. We can directly access them in our callback function. So for query parameter, we have another object in request, which is request.query. And that's it. We don't need to do anything in our endpoint. Save the changes and take a look. See, here we get the query object. So request.params is used for route parameters and request.query is used for query parameters. We will use them a lot when we build complex APIs. They are very useful. Now let's see how we can return single to-do by its ID. So for that, what we use? Route parameter or query parameter? Right, we will use route parameter because that information is must required. So we remove this /status from our endpoint, we don't need it. And in the callback function, we need to return the single to-do which ID is the same as our route parameter ID. First of all, let's store the route parameter in separate variable. So const to-do ID equals to, how can we access route parameters? Right, request.params.id. Now we have to find the single to-do from our to-dos array which ID is same as this to-do ID. For that, we use one JavaScript array method which is find. So to-dos array.find, and inside this find method, we pass callback function, and here in the parameter, we get the single to-do object as t. So this t is this single object in the to-dos array. And we return here condition if t.id equals to our to-do ID. If you don't know this find method, then let me explain you in short because it is pure JavaScript concept. So this find method will check our to-dos array, and first it will pick the first object of the array in this t variable. Then we check the condition t.id is same as our to-do ID. If it is true, then this find method will return that single object. So we store in variable const to-do. And also, if this condition is not satisfied, then it will set t as next object and then again check the condition. And that's how we can find single to-do using this find method. Let's also send this to-do in res.send method. Save the changes and take a look. Let's remove these query parameters and also status value. And here we don't get anything. Why? We pass ID 1 and in our to-dos array, we also have to-do with ID 1. Then what is wrong? Let's try to console this single to-do. Save the changes and refresh the page on browser. Now in our VS Code terminal, where we are running our server, we get our consoles. See, here we get undefined. So we cannot find to-do from our to-dos array, and that's the error. May this error occur because we are not comparing the IDs properly. Let's also try to console this to-do ID type using type of to-do ID. This will return the type of to-do ID. Save the changes and refresh the page. Back to VS Code and see, here we get undefined for single to-do and we get type string for to-do ID. And that's why we are not getting single to-do, because here our to-do ID is integer and we are comparing it with the string. So we have to convert this to-do ID string into integer. So we can wrap this request.params.id with parse integer. This parse integer function will convert our string into integer. Save the changes and take a look. Refresh the page and see, here we get the single to-do object with ID 1. If we pass here ID 3, then we get here to-do with ID 3. So it's working. Good. Now you might ask, in the route parameter, we are passing 1 as integer, but why in the backend we get it as a string? So the truth is, whatever we pass in the URL, it is passed as string. So if we want to pass something as integer, then we have to convert it in the backend. We can't pass integer value using route parameter, and it is also true for query parameters. So always remember, when you define route parameters or query parameters, then you have to convert its value using parse integer or parse float method. I intentionally create this error to show you what might happen when we create API and access ID in the route parameter. Now let's create post API for adding a new to-do object. So as we know, for creating new data on server, we use post API. And also in post request, frontend will send data to the server. For example, here we create post API for adding a new to-do. So our frontend will send details about the to-dos like task, tags, and status in the body of that request. Without this information, how can we add new to-do in our to-dos array, right? Don't worry, let me show you this practically. So here we define post API using app.post, and at the first argument we pass our endpoint. Let's pass /todos, and at the second argument we pass callback function with two parameters, request and response. Now you might ask, these two endpoints are same. How can we use these APIs individually? So here we can see this API used get method, and this second API is used post method. So when frontend send API request on this endpoint with get method, this function will run, and if frontend send API request on the same endpoint with post method, then this function will run. We will see how to send post request in just a minute. Now, as we know, from frontend we send data in the request body. And how can we get information related to request in this function? Right, we can use this request parameter. In this request, we will get all information about that particular request. So here we have request, and in this request we have property called body. This body has all data which frontend sends with the request, which is our to-do object. So we store it in variable called to-do. And after that, simply console.log this to-do, and also response.send this to-do. Now let's test we are getting data in our to-do variable or not. Previously, we are sending simple get request from the browser URL, because by default, browser send get request to the URL, but we cannot send other HTTP request using browser URL. For that, we need front-end code, or we can use API testing software like Postman, or we can also use one VS Code extension called Thunder Client. From these three options, installing VS Code extension is much easier setup. So in this course, most probably we will use Thunder Client and Postman both, because for testing advanced API we need Postman. But don't worry, both interfaces are same. Main thing is we should able to test our API. Simple as that. So head over to extensions panel from here and search Thunder Client and install it. Now in our panel list, this Thunder Client icon is added. So let's open it, and here we can test our APIs for our project. So first of all, we enter our API URL, which is http://localhost:3000/todos. And which method we need? We need post method. So we select post from here, and now we have to pass to-do object in our request body. So for that, we select here body, and in the JSON option, here we will pass our data in object. First field we need is task. So we have to pass field name in double quotes, and also we have to pass value in double quotes. This is new task. Also, if you can't see these fields properly, then close this panel by using Ctrl+B or Command+B. After that, we need another field which is tags, and we pass here array, and in that we pass two values, HTML and CSS. And last field, status, and value, let's say to do. Now here is one thing, this field name which is this task, tags, status, these names are set by the backend developer. Whatever name backend developer define, frontend developer should send data with the same field name. Otherwise, how in the backend we fetch data from the body of the request. Now for sending this post request, we click on the send button. See, we didn't get anything. And if we check our terminal, then also we get undefined. So why we are not getting the data in our request.body object? What we are doing wrong? So when frontend sends post request, it sends data in the body of the request in JSON format. And that's what we also did in our testing request. Now by default, Express server does not know how to automatically read and understand that JSON data. So for Express, we need a translator which will convert that JSON data in a simple JavaScript object. Because we cannot directly work with JSON data, we need to convert it in object or array which our JavaScript can understand, right? So for that, we have one middleware in Express which will work as a translator. So after this todos array variable, we add app.use, and in that we call our middleware express.json, and that's it. Make sure you add this middleware before our APIs, and also you have to call this express.json middleware, otherwise it will not work. So currently, without this express.json middleware, we are getting request.body as undefined. Now let's save the changes and again send post request. See, now we get our request.body same as we send this object. So this is the importance of express.json middleware. Now we have to just add this new to do in our todos array. So we use here simple array method todos array.push. This will add new data at the last position of the array. And here in the push method, we pass object because all our to-dos is in object, and we have to follow the same object structure for the new to-do. So first of all, we need ID. And how can we get the ID? We didn't pass it from the front end. So for ID, we can do something like this. We will get the last to-do ID and increase it by 1. So to get the last to-do of the list, we write todos array in square bracket todos array dot length, which is currently 3, but we know array index start with 0. So we have to do here length minus 1. So this todos array in square bracket todos array dot length minus 1 is our last to-do object, and we want to access its ID. So we add here dot ID and simply increase it by 1. So if our array length is 3, then 3 minus 1, which is 2, which is the index of the last element. And then we access its ID and increase it by 1, which is 4. Simple as that. Next, we have task field, and we pass value as to do, which we get from request.body, and for accessing task, we add .task. Next, we have tags, and we pass value to do.tags. And last, we have status, which is what? Right, to do.status. Now I think this might confuse you. So we define this new to do object separately. So const new to do equals to paste this object here. and in the push method, we simply add this new to do. I think this looks more clear. Also, one thing I want to tell you, in any API, at the end of the callback function, we must add response.send. Otherwise, on our front end, our request keeps running, and that's make our overall speed down. So make sure in every API we return something. Now you might ask, what should we return from the post request? So from the post request, we can return recently added data in our server or database. So our front end gets all the information like ID and use them as they want. So here we simply return this new to do, save the changes and take a look. Send the request again and see, now we are getting data with ID 4. And if we fetch all to-dos from the get request, then see, we get 4 to-dos. So we successfully create post request and add new to-do in our to-dos array. Let's quickly recap what we learned in this lesson. So we use post request for create a new data on the server, and we get that new data from the body of the post request sent by frontend. For testing that, we use this Thunder client extension and send our data in JSON format, which is the common format for sending data. Now in the backend, we need to convert that data into simple JavaScript format, and that's why we use express.json middleware and add it before our APIs. Without this express.json middleware, we are getting request.body as undefined. After that, we add the new data in separate object with its all field and then simply push it in the to-dos array, and at the end return the new added data from response.send. Simple as that. Now in the next lesson, we will improve this post request. Now currently, our front end is sending whatever data they want to send. But what if someone don't send the required data like task tags or tags array or status? Without them, we can't add incomplete data in our storage. It's bad for our application. So in that condition, we have to add data validation in our API. So at the beginning of our API, we will check frontend is passing all the necessary data or not. If it is not passing proper data, then we stop that request immediately with proper error message. Let me show you what I means. So here, after we are getting the data from the request.body, we add simple condition if todo.task is not available, then we return error from here. So in the curly brackets, we write response.send task is required. Now here is the one thing. Even if we write here response.send, our remaining code will also work. So to stop running the code from here, we have to add here return. Without this return, our remaining code will anyway run. So don't forget to add return. Now let's duplicate this if block 2 more times using shift plus alter plus down arrow or shift plus option plus down arrow. Now we simply change the condition for tags to do.tags and change the error message tags are required. And at last to do.status and status is required. Also, here we can check more conditions like tags should be array or task value should more than 3 characters, etc. For now, we don't want that complexity, so let's test this implementation. Save the changes, open the post test, and we simply remove this task field. Send the request, and see, here we are getting this message, task is required. Beautiful. Now front end just need to display this error message on the form or anywhere they want to display. So by this way, we can manually validate our input fields data. But these are only 3 fields. Imagine we have 7 to 8 fields, and for each field, we want to validate data. Then we have to write this if condition 7 to 8 times. So is there any other way to do that? Yes, we have special library for validating the user data. First one is Joy. This is one of the most popular and robust data validation library in Node.js, and we will also use Joy for data validation in this course. Also, there are another library like Yup and validator.js. You can use any of this library. I personally like Joy, and we will use Joy in the next project. Currently, our main focus is on creating CRUD APIs, which means create, read, update, delete APIs. Now when we return an error from the server, it's better we also pass the error code with that error message. By that error or status code, our frontend gets information about the success or failure of the HTTP request. You might already know about this, or you might seen this error. For example, when we don't found a web page, some website display 404 not found page. This 404 is the error or status code for not found. Let's see most common error or status code for HTTP request. So first one is 200, which means all okay. This is the default status code which sent by our Express application. And in our request also, we can see here we are getting status 200 okay. Next we have 201 code, which means created successfully. So if we create a new data on our server, then we can return that data with status code 201. Can you tell in which HTTP method we can return status code 201? Right, in the post request if our data is successfully created. Next, we have status 400, which means bad request done by frontend. These include some missing or invalid or unauthorized access request. And yes, for data validation, we will return error message with this 400 status code. Next, we have 404, which means not found. Suppose we are sending GET request for getting the single to do with ID 10. Now that is not available in our data. So at that time, we can send response with 404 status code. Another important status code is 500, which means internal server error. Suppose we get some error in creating the new to-do on the server. Then at that time, we will return response with status code 500. There are many status code, but for now, these are most useful. Don't worry, with practice, you will remember all those status code. Now for passing the status code with our response, we can add here multiple cursor. So press Alt or Option and simply click where we want multiple cursor. And here we add .status, and in this with status code we want to pass for invalid data. We pass 400 and that's it. Press Escape for remove multiple cursor, and that's how we can pass status code with our request. Also, if we successfully create data, then we return response with status 201. Save the changes and take a look. Send the request again and see, here we get error status code 400 bad request. Lovely. Now till now, we are sending the response using response.send method. But this response.send method is used for general purpose, which means in this response.send method, we can send any type of content like plain text, HTML, or we can also pass JSON data. Now when we create API in Node, most of the time we want to return data in the JSON format because it is much easier to handle. So here in the response, we have another method called response.json. This will automatically convert our data in the JSON format, and also it will set header content type to application/JSON. Don't worry, if you don't know about header content type, we will see that in the next section. So we will use response.send for simple responses, whether text, HTML or objects, and we will use response.json when we want to ensure that the response is in JSON format and properly formatted for JSON clients. Both works almost the same, but for JSON data, response.json is more convenient. So in the first GET request, we want to send the plain text. So we use here response.send. After that, we want to send to-do array. So we can use here response.json. Next, also we want to send object, then what we will use? Right, we use response.json. And let's also remove this console. We don't need consoles in our server. It is just for testing. Next, here we are returning error. First, we change this send with JSON, JSON and JSON. And it's better we pass that error in object. So wrap this string in object and simply add here message property and colon. Same we do for this error and also for this last error. And when we successfully creating a new to-do, then we are returning the new to-do object. So we also change this send with JSON. Make sure you don't pass plain text in the response.json method. It will give you error. Save the changes, and in the previous testing, go to the header section. Here we get bunch of details, but for now we need this content type. See, it is set to text/html. Now let's send another invalid post request. See, here we get the object which we sent with message property. And now if we check our content type, see, it is set to JSON. So use response.send for plain text or HTML and use response.json for sending JSON data. Now let's create an API for updating our single to-do. Suppose we want to update text of task or we want to update the status. So here we want to update little details about our current data, or we can also update all the informations. So it's better we use here put request. Also you can use here patch method, it's totally fine. So app.put endpoint to /todos. Now here we need the to-do ID which we want to update. So we add here route parameter :id. After that we add callback function with request and response. Now first of all, let's get the id parameter. So const id equals to request.params.id. And we know that this id is string. So we wrap it with parse integer function. Now our first task is we have to find which element of the array has this id. And then by that element index, we can change other values very easily. So for finding the index, we use todos array.findIndex method. Here we get single to-do object in this t, and then we pass condition t.id should equals to our id parameter. This expression returns the index of the element, so we store it in variable called todoIndex. Now what if user pass id which is not available in our array? At that time, this todoIndex value will become -1 because this findIndex method returns -1 if we don't found the todoIndex. So here we pass if condition todoIndex is equals to -1. Then we return response.status 404 which is not found, and then .json, and we send object with property message and simply return here message to do not found. Make sure you add here this return. Great. Now suppose we found the to-do index, then we have to update that element fields with our new data passed with API request. So at the top, first we get data from request.body and store that object in to-do variable. Now instead of defining 3 different variables, we can use here object destructuring. So at the place of variable name, we can simply add curly brackets and write our property names which passed in the request.body. So first we get task, then tags, and then status. And that's it. This single line of code works the same as these 3 lines of code. Now in the update, not every time we change task or we only change status, we can change any of these 3 properties. And our front end should pass only those properties in the body of the request which they want to change. So here we can do something like this. If task is available, then we update todos array todo index dot task is equal to task. So if this task is available in the body request, only then this line will update the task property. Let's duplicate this if condition 2 more times. Let's replace this task with tags, tags, and tags. Also this one status, status, here also status, and that's it. Also here we are missing one thing. Can you tell me? Right, we have to return response at the end of this function. So response.json, and here we send our updated todo object. So todos array in square bracket todo index. Save the changes and let's test this implementation. So go to Thunder client and create a new request. Write our endpoint which is http localhost 3000/todos/. Here we pass todo id, let's say 1. Change this get method to put method and let's pass data in the request body. Object with property task and value to this is the updated task. And simply send the request. See, here we getting the updated data. And if we pass here id 10 and send the request, then we get here error message not found. You can see how simple it is to create API. Also, if you want to save your test, then press Ctrl+S or Command+S. And then from here, we can also rename our test request, update todo. Now it is time for interesting exercise. You have to create API for deleting the specific todo using its ID. This is a lot easy exercise. Exercise will help you to learn fast and also boost your confidence. And even if you can't complete the whole exercise, at least try to solve it, because that's how you know on which part you have to work more. So give it a try and then watch the solution. So I hope you solve this exercise or at least try to solve it. Now let's quickly see the solution. So here we define a new API using app.delete because we are deleting data here. Endpoint /todos/:id callback request response and arrow function. Now first of all we get the id from the route parameter. So const id equals to request.params.id and simply wrap it with parse integer function. This parse integer practice is very useful because when I am learning Node.js, this one mistake I repeat a lot. So make sure you don't repeat this mistake. Now here also, first we have to find the index of the todo object which has this id. So from the put method, we copy this variable line and also we copy this condition for not found and paste them in our delete method. Now after that, we have to simply remove that specific todo from our todos array. So for that, we use todos array.splice method. In this, we have to pass 2 arguments. First, which index we want to remove, which is this todo index. And second argument is how many elements we want to remove from this index. Suppose we have index value 2 and here we pass 3. So this splice method will remove 3 elements with the index 2 and also it will remove the element with index 3 and 4. In our case, we just want to remove this single element. So we pass here 1 and at the end we simply return response.json and here we pass success message, so object with message property and value to do deleted successfully. Save the changes and let's also test this delete request. Create a new request, change the URL to http://localhost:3000/todos/ let's delete the task with ID 1. Select delete method, and here we don't want to pass anything in our request body, so send this request. See, here we get success message, which means our task 1 is removed from our to-dos array. Now if we again send the request with the same ID, see, here we get not found. Lovely. You can see creating APIs is not that much difficult, and in this section we created get, post, put, delete, all CRUD APIs. So I hope you understand how to use Express and create REST APIs with Express. So I hope you enjoyed this mini course, and these are just 3 sections of my full Node.js course which I just launched recently. In this course, you need to know about Node.js like MongoDB and Mongoose, pagination and infinite scrolling, user authentication, as well as sign in with Google and sign in with Facebook features, sending emails from our backend, uploading multiple images, handling and logging errors, apply full payment integration using PayPal, and also real-time chatting features using Socket like sending one-to-one messages, showing typing indicators, handling message status, is it sent, delivered or seen, and also group chat features, and much more. You can check this course if you want to learn Node.js in simple and easy language. Link is down in the description. Open that link and you can enroll in this course.